Alright, what we got here is a scalable system. So we have 4 central processing units, and we've sectioned up our GPU processors, because we have a bunch of them in there, to allow each CPU to have access to a certain number of GPU processors. And then those GPU processors are going to communicate to the displays. Now right now you could write code to do this already, but because of the current way that they display, you're going to have to print instead of being able to update them all at the same time. So anyways, you have a player controlled screen through a local bus, like a controller, like maybe a USB controller of some type. You have player controlled through the network. You have CPU controlled artificial intelligence, and so you could have a CPU controlled artificial intelligence player, and if you had more CPUs you could have a whole bunch of CPU artificial controlled AI out there that were individually controlled by a CPU. And then, you know, this could be anything. So the signal has to be broadcast in every direction at the same exact moment. But what will determine who receives the signal, this person might be sitting 3 feet and this person might be sitting 5 feet, but this person that's 3 feet might have a piece of glass in front of them, and that glass could slow down the whatever the light is that gets to them, to where this person receives the signal sooner, because it was broadcasted at the exact same time. The AI is a central processing unit, so it may see the signal even faster. And then this person's out here on the network, it may take it a second for the packets to reach them and then hit their display. So it'll take them even longer. On here. Java Lightweight Game Library. I'd like to see some Java hardware implementation. So say this is your Raspberry Pi. It's got, the new one has a quad core. It's got GPU, it's got a graphics port. Quit using the HDMI port. Can we use the graphics port to communicate to our displays? Why? It can transfer more data, I believe. So you're going to need more data if you're going to be controlling every single pixel individually to be able to go through that pipe. These use multi-layered PCBs, so you can imagine like a bus going from these processors to these GPUs to, and then a bus going out to here. So you'd think if you drew lines on here which represented the connections, well, you couldn't cross those lines, but because it's a multi-layered PCB, some of the lines can go down and then over to reach other ports. Okay, so the machine code is translated from the C, or the assembly code. What I'm saying is there'd be a Java machine. So you could take an SD card like on the Pi, and you could put just enough instructions to translate Java bytecode into machine code. But I would like to have a Java bytecode processor So you could implement this in software using the SD card. But I would like to have it built into the processor to where then you put just the machine code for the Java bytecode on your SD card, and then it would boot directly on your, so you could write everything in Java. Okay, so Java Virtual Machine can be ran on a Linux host. So here's the Java Virtual Machine. He's so happy. And he's taken the C hardware. So you got like the Linux kernel locates its kernels are. The operating system's great because it can manage your files, your videos, and everything you want to do. So that's been compiled in C. And then if you want to put it on new hardware, like let's say you have a Android TV stick and you want it to run something like Linux. If the hardware manufacturer doesn't give access to the code for the USB driver or the HDMI driver or any of the hardware devices that are connected to it, then you're not going to be, you'd have to reverse engineer it and write your own, which is time-consuming process. So because he's a virtual machine, he just comes right in here and uses whatever works at the time on the host machine that has been released. So he can run on a raspberryPi, Raspbian image. He can run on all kinds of stuff, as long as everything works down here. So you could take him and build him on an SD card. He brings OpenGL to the table, which is really nice. But one thing to remember is that the code can be ported over to C. The nice thing is the Java Virtual Machine could be ran on headless Linux, no display. That's what headless means. And then we could make a display with OpenGL 3D with the Java game library. So then we would give it a head, we'd give it a display to where we could see what was going on in there. This is where we get into seeing two images at once from different points of view. So Blender is a 3D modeling and texturing program. It does more than that, I believe. But basically you have a camera that views an image. If you've never seen it before, what it looks like would be like that. You can make that's a 3D cube that was created in Blender, and that's a 3D sphere. Okay, so anyways, Blender's missing an eye. You can only focus on one thing. So what I had to do is I had to take an eye, and I had to look at something, and I had to take a picture of it. Then I had to move the eye over, look at something, and then take a picture of it to get a perspective. So if they could code in another eye, that would be great. Let's see, eye focusing 3D image capture takes a pic and then next combines them into 3D formats. 3D formats being 2D 3D formats like JPEG. Allows for frame by frame animation. 3D movies. That's what we're getting into. So how do you adjust the focus whenever you're programming that? If this ball's moving this way and this is rotating over here, what are you looking at? Are you looking at the ball that's moving over here? If you're looking at the cube that's spinning over here, if you look at this one and take a picture, the distance is different. If you look at this one and take a picture, the distance is different. So you can't look at both of them at the same time. But it appears that there is a range of view where everything is always in focus. So if you made one eye program that always put everything within that range of focus, it would always be in focus. Possibly, I don't know. That would need some experimentation. Okay, so you write a program that takes a stack of those JPEG images. So it took one picture, took the other picture. So we've got two pictures. And you combine them into a file. So now you have a 3D picture. So then you take all those 3D pictures and you combine them into a container, which would be a file, movie formats like AVI, and now you have a 3D movie. So then you could use the AVI file and load it into a program where you could add audio, you could cut the video file into segments, so you could edit 3D video files. You could add audio, lip syncing. You could play the file on a 3D display. It already works. You'd get the So the concept works. I was going to show you that that it works right here. This is my 3DS. Okay, see the image changed? That's because there's two images in this file. So it's displaying it as 3D. Now you won't actually be able to see the 3D, and everything's not syncing at the same time. But there. So the concept works. You could make 3D movies with audio, and we could build the software, but we're going to need like a team of people because that's a lot of work, and they're all going to have to, if it's going to be open source so that it can run on the raspberryPi, probably the best way to do it would be the quickest way, which just would be to make the SD card for the Java virtual machine bytecode, and then get the Java game library, write to an OpenGL screen while simultaneously developing the new screen hardware and how that'll all be implemented. I don't know. Just something to think about. That's what I've been thinking about and kind of working on. It's pretty exciting stuff when you think about how you'll be able to focus on multiple points or control multiple 3D screens all simultaneously.